Wah! Howdy, everybody. Tonight, we continue 30 Days Lost in Space. We are on day 24. We are 72% of the way to completing this. After this, actually see where we're at here. After we're done with today, we've got one more creative day, and then five days left. So, where we left off from last time is two displays hooked up. We've got the OLED display, OLED, which is the one with a bunch of little pixels on it. And then we've got the 7-segment display, which looks like a blinking clock when it has no time set. It's the display that looks like that one. If you shut it off, it all looks like 8s. And then today, we're going to be building on that fact. So we're going to be bringing some stuff back that we had in previous days and integrating it into today. So let's hop into it, shall we? He's doing still having some problems.
Explorer.
Yeah.
Launch day. Up for it?
Maybe.
Let's just do another gear check.
Sure.
We're at a critical juncture, so let's go over what's in store.
Do I believe
We
you?
have a full roster of equipment to wire up. Number
Hopefully.
1, our dip switch. To
Excellent.
toggle all system functions and initiate the countdown of our 7-segment display.
Dippy switches.
Number
Very
2, our OLED.
Got
Which
it.
will serve as our control panel display. And
Yup.
number 3, our trusty buzzer.
Aha,
to keep
we're
us
making sound
alert in
again.
case of any safety concerns. Our task is immense, our hearts are stout, and our minds sharper than ever. So, let's roll up our sleeves, strap in, and prepare for liftoff. The vastness of space beckons, and we will answer its call. To paraphrase an ancient Terran, too close to infinity, but never beyond. We're going to put together our
See what you did there.
OLED, 7-segment display, dip switch, and passive buzzer into one masterful circuit. This intricate symphony of hardware will be the central nervous system for our liftoff. The OLED will serve as our main control panel display.
Okay.
The 7-segment display will take care of our crucial countdown.
Got
The
it.
dip switch will be our trigger to initiate all
Flippy
system
switches,
functions.
my
And the
fave.
passive buzzer will be our trusty watchdog,
All
alerting
right.
us of any anomalies. Today, we are adding the grand finale to our code. But before we initiate the spectacular conflagration that will power our escape, we need to start with the smaller sparks.
Okay.
It all begins with our dip switch. Dip switch. 3 systems all need to be on before we're a go to launch. Timer is wired up correctly and, well, to the 7 segments. Eyes on the clock. And then we'll see what happens.
Got it.
There's some instructional material, as usual.
Naturally.
Check things over. I'll do a flight check, Gotta make sure. Good luck.
Hello, everybody, and welcome
Bye,
back
Alex.
to day.
Bye, Alex. Yep. Okay. Let's get us ourselves back into action. Right. Okay, so picking up where we left off, we already have our displays connected, and this is the new stuff that we're going to be adding in today. Things on the breadboard. The whole idea here, for those of you that are joining me now, is that this whole project is built around the idea of you being on a spaceship that is currently on the surface of the water. For the last many long days, we were on the surface of the ocean because we sank. So we floated back to the top in fantastic fashion. And now we're going to wander through all of the checks of the different systems. In this case, there's 3 of them. Well, technically 2 systems. We've got our thrusters, we've got the system control, and then the third switch is our confirmation switch. If at any point one of those switches is turned off, that is where the buzzer comes into play, is to activate and stop the code mid-execution and go, whoa buddy, we're not ready to go, and cancel the launch of the space shuttle. Now, there's some interactiveness to this because we've got the fancier display. The OLED is many pixels dense, which allows us to make many different things appear on it. So we're going to use that to our advantage. Some of this code is going to look familiar from last week, which is no surprise because we're going to be reusing some of the same hardware. But I'm going to switch us over to the camera, and then we are going to start wiring things up. We're going to make sure that they didn't accidentally move. Well, I can't necessarily say accidentally. We're going to make sure that they didn't move where the components are previously connected. I'm imagining that's still going to be the same, but regardless, we're going to make sure that's the case. So let me switch this over to the bench and let's get to it. Okay. All right, with that, we've got these items connected. Now, something I do want to note that we are going to bring over from last time is the line of code that flips the display upside down. Because technically speaking, right now, I have the display installed upside down. Right side up would be the other way around. But to save me from having to rewire this, there's a line of code that just flips the display around so that the top becomes the bottom and the bottom becomes the top. That's a nice software way to accommodate the fact that I have it installed upside down. But granted, they did that on purpose to provide that little line of code, because I'm sure I'm not the only one that stuck this into the board and have it presented in a fashion that kind of gets it out of the way, which is where we're at. So, welcome on in, Pyro. We're doing more with the 30 Days Lost in Space franchise this evening. So on the docket, we need our passive buzzer. We have that guy right there. We need our dual inline package switches, also known as our dip switch. If I can get this to focus. There we are. So there's those. We have those, and then let's see what we need. We need 3 resistors that appear to be 220 ohm is what that looks like. I will confirm that momentarily. Once I get the resistors out of the bag. Let's see, let me get that out of the way, and I've got this 2 red, 2 black. Let me see what we have here on the color bands. We've got 2 red, 2 black. Yep, 220 ohms. Okay, so I need 3 of those. I've got 1. And then let's see. I know there's more of them in here. Give me a moment. These are a little scattered and kind of small. That's 1K. That's 10K. Okay, so that is 2 of them. Now right now they're not currently connected. The board's disconnected from the computer. So there are 2 of those components, and then I'm going to have to locate one more. $1K, that's 10K. Let's see here. I currently seem to be short a resistor.
Now I could use a slightly different rated one, but give me a moment. I do have a kit of these. And this kit has 220. That's what I'm looking for. Okay, cool. Because naturally, even though I believed I put them all back in the same container, that apparently doesn't seem to be true. But that's okay. That's why we keep backup parts. Especially with something like resistors. They're small and they're very easy to misplace. So, because they're so small. So let's see. So 47, that's 100. Alright, so these are in order, so I'm going to be careful that I don't mix up the order here. So let's see here, so we've got 220 is black, black, red, red. And just like that, from my stockpile, there we are. So we've got 220 ohms resistance, and the colors do match the ones from the kit. So that saves me a little bit of troubleshooting with what I ended up doing with them. Problem is that I've worked on several projects in the background off camera, and I can promise you that I didn't lose them. They're just sitting inside of another project board that I currently don't want to disconnect. But that's okay. We have extra ones. Alright, cool. That out of the way. Alright, that gets us off to the races here now. So, looking at our wiring schematic, we're going to have the 3 of these on one side of the dip switch. We're going to bridge from... Okay, so we're going to go... So, for those of you that have not seen this before, electrically speaking, let me get these little components out of my way so I can show you what I'm referring to here. Electrically speaking, this break that's in the center of the board, there's like a dip here, is not electrically connected between the numbers on the left or the right side of the board. So when I place this component and bridge the gap between the two sides, that is electrically separate between sides. Because what we're going to do is we're going to send voltage in from one side of the board through the switches to the other side and measure it using our hero board, also known as Arduino. That measuring of those voltage drops is what's going to indicate to us whether our switches are on or off. Again, we've seen this in the past, but we're bringing it over to this project to kind of really cement the idea of this journey we've been on. So I'm going to get this set, and we're going to set this on pins 16, 17, and 18. That's what we're going to do. So I'll pop that right in the center of the board. Actually, you know what? Let's move that a little bit near an edge. You know why? Because we're going to be actually looking to toggle these on or off. So let's use the last 3 on the board. 29, 30, 28, 29, and 30. So then we can easily toggle the switches on and off, and then we'll put the buzzer, the speaker over here. That'll make things a little easier. Now, as far as it goes right now, the rails that are on this side of the board are not electrically connected to anything because I have everything joined over here. So what we're going to need before we hook anything in on this side is to join both of these sides together. So we're going to do that next. As far as the board is concerned, it doesn't really matter to it what color wires you use for jumper purposes. As you've seen in previous episodes, I kind of use whatever color is floating to the top. But usually I try to keep the colors somewhat organized so that I just have a little bit of an idea of what's going where here. So we're going to go ground to ground. And then positive to positive. Like that. And like that. So now, anything on this side is the same as this side with the impedance. Howdy there, Set. How you doing this evening? It's okay. That's why I take it a step at a time. I'm bringing everybody along for the ride. Oh no. Hi, Alan. Oh no. Oh wait, no, is that the dead one or is that the sipping coffee emote? Oh no, it's the dead emote. No dead. Less dead. I can't say I'll promise you it'll make more sense when I'm done, but I'm pretty sure at this point it's kind of complicated. And I can't argue that fact because it is. But the thing that I like to do with this, thank you, Asad. The thing that I like to do with this is to break this into smaller pieces, right? Because we ramped up from just using one of these pieces at a time. And then what we did is just combine them into a bigger project that just uses more of these at once. The difficulty of each individual component didn't go up. We just involved more of it at the same time. And then the different code allows us to manipulate and do different things together. Which one do you got to stop the bomb? Well, you say that, but we're going to make beeping sounds this evening. So if you're listening to me, better not be doing it in an airport because this little guy might scare some folks off. Do be careful now. That joke is for educational purposes only. Let's see here. All right, so we've got our speaker that we're going to pop in here like so. And then let's see what we need for switches. We need to go from the grounding rail to the positive rail. All right, maybe we'll scoot the speaker over a little bit. Put that there. Because the positive side of this set of switches I am going to have to attach down here. That's okay. So let me get our resistors in place and then we'll run off with that. A set you might be, but I don't know if you're necessarily TSA pre-checked to be yeeted into outer space. Do be careful with that. A mini fire alarm. You know what? you know what? I didn't even think about it. This would be the perfect thing if you're trying to make an endlessly chirping smoke alarm. Like, what flavor of evil are you today? And the answer is yes. Okay, so the fun part about having all these components on top of each other is I need them to not touch each other. Not because anything bad will happen, but what we'll have a bad reading from our pins if these components do touch. So one of the benefits of having these directly soldered onto the project is that you don't really have to worry about anything touching anything. Because everything's already kind of where it needs to be. More or less. Now, another thing too is I don't have this currently connected to power for obvious reasons. High-pitched yanks. Alright, got that in there. Let me get this in there. Carefully. I say carefully. I don't know if I'm careful enough. I feel like I'm careful enough. Maybe I am, maybe I'm not. I don't know. Alright, so we do need to get a reading on these pins. So that's going to be fun. So that means I need to get us 3 more wires. Like these ones. And I'm going to go from left to right here. And I try to do this in a way that I can get these in here. What I'm going to attempt to do is I'm going to attempt to get the reading between these. I do need to plug all of them in for us to get the reading. I say as I casually attempt to attach those all. Okay, cool. So right now we've got where we're going to take our reading. Right now I don't have them currently hooked into anything. They're just kind of hanging out there in the breeze. And then we're going to connect the other end of this to power. So that involves 3 more wires that we have to hook up. Let me get us a couple more jumpers here. let's see, those are not the kind I need. I need this one, and then I need... Actually, you know what? I could just steal one color off of this. Make it 3. Now the nice thing is the other side of this can go anywhere on the positive rail, which is going to be 5 volts. So all I have to do is very carefully just plug these all in on the other side. And again, it doesn't really matter where these go per se, as long as they all lead back to 5 volts. Because it's going to start at the 5 volt side, and then it's going to go down a pin at a time, and it's either going to go through or it's going to hit the switch and stop. Now this is where things get very tight quarters. So we're going to be extra careful with plugging all these in. Okay, so as per the diagram, which is very diagram shaped, I've got 5 volts coming in from the top. We've got our probes that we need to hook up to the board, and then we hit the I know what those resistors are called. There's a name for them. Pull down resistor. That is the phrasing I'm looking for. So when you're running electricity from one side of this connection to the other, even though we're going to read the voltage drop with this directly connected to our board, what's going to happen though when the switches are turned off, there's going to be some voltage just going to be floating out on this side of the pins. And these resistors drop or pull down that additional voltage to the negative rail, which keeps the readings consistent and gives it so that it gives the impression in the sense of something our board can actually understand. If those are not present, we can expect readings that won't be consistent, which would be problematic. Okay, so looking at our diagram, we're using pins 7, 6, 7, and 8, other way around. Okay, cool. So we're going to very, very carefully connect these to the board. Looking at this, the bottom corner, I might not get these right on the first try. The way I have the diagram oriented, I guess I could spin it. It'd be less silly technically, because that's the way that it shows it in here, right? So from this orientation, the bottom corner, which is the very bottom one, goes into pin 8. And then after that, we've got 7 and 6. That is such a weird orientation to do that in. Alright, so that means that blue is going to go into pin number 8. That's going to be over here. 8. And then second in command is going into pin 7. And then 6 directly after it. So I could just bring these down together. Like so. Okay. Now our rat's nest grows. Alright, I've got the dip switch wired in. So then now that leaves us now is to wire in our buzzer. So our buzzer is going to require a total of 3 wires. Let's see what we're working with here. Is that just 2? 2 wires. Okay, so our positive side goes directly into our fancy board, our hero board, and then the other line goes to ground. Okay, so we'll wire up the ground first all by itself, because why not? Now, I stuck this in here, and I don't remember which way I oriented it, so we're going to look at this, and we're going to see that the minus symbol is on the left by my thumb, and by my pointer finger is the positive. So we have negative down here and positive up here. So, knowing that information, I'm going to pop this back into the board, and we're going to put pin 14 on the negative rail. So we got 14 goes to ground. And then we need to hook up our positive. Now, our positive was the far edge. So we're going to go, I'm going to skip the center. And then that just leaves our signal wire. So then the board's actually going to pulse this to be able to make the different sounds. And that gets plugged into pin number 9. Now, pin number 9 is not a normal pin. It is known as a PWM pin, or the fancy phrase, pulse width modulation. That allows us to rapidly turn the pin on and off. That comes in incredibly handy when we're trying to control light, or if we're trying to control sound, right? Because that allows us to take the electricity and rapidly turn it on or off. So, as far as the hardware is concerned, let me quickly double check to make sure that the displays didn't move. Pins 4, 5, and 6. You are on 4, 5, and 6. And then our analog display is on analog pins 4 and 5. Exactly where we left them. Okay, cool. So, now that we have things hooked in here, let's see what we're actually going to have happen in here. We're going to have our countdown appear on this display. We're going to have our system stats and the state of our switches on this one. We then will have our buzzer on the board that will indicate to us if there is a problem. And then we have our switches right here that allow us to actually change the system status from on or off. So, since we have code on this from the previous day, when I plug this in, we are going to run the program from the previous day. So, we're going to see some stuff on the displays, and the lander is going to go through its liftoff procedure. And we can see here that the liftoff sequence was aborted. Now that is exactly, whoop, one of our wires came out. This is the one for the buzzer. Hold on a minute. That didn't feel like it seated very well. Let me grab a different wire for that. Let's use this red one. The only thing about these little push-in connectors is that they do wear down over time. And then this was in pin number 9. Number 9. Okay, there we go. Okay. Now, we can see here our countdown hit done. And we can see that our thrusters are off, our systems is off, and our confirmation is off. Countdown was aborted. And that's because we didn't have the hardware for our switches, which is what we have over here, the little red pack that I plugged in. So now we're going to leave that right where it is. And we're going to switch over to the code, and we're going to make the code actually see that hardware we have that's currently attached to the board. Because right now it's there, but until we tell the developmental board that it's there, and it's not going to do anything. Captivating, I know. Actually, no, here, let me flip this and put this underneath this cable, just so for my sanity's sake it's out of the way. I'm gonna make things a little easier to see. There we go. Less things crossing over other things.
In addition, we're adding the buzzer module to provide us with audible feedback and warning indication.
Okay. Good news. We weren't on that scene, so we didn't see that audio. Camera. We doing? And give me 1 second. Position got reset. Boop. That's better. Okay, cool. Okay. Now we have that sorted out. Let's see here. Okay, I'm going to open up the previous day's code, and we're going to pull out that one line that allows me to flip it upside down. That way, I don't have to rewire the display. Oh, interesting. It reran the code. Huh. Okay. Alright, so I need to grab out of the setup from the previous day the stuff that flips us around. I think I stuck it near the top. Here it is. Set rotation. I'm saving that for later. Cause we're gonna need that. Alright, cool. Now that we have that, we can start for today 24. It's the only thing I need to pull over. Okay, so before I get started, the first thing I'm going to do is just reset the project by uploading this blank sketch. So I'm uploading code that has nothing in it. And then once that's been done, funny enough, what you see on the display won't get cleared automatically. I have to actually tap the reset button that's on our board to actually clear it. That's this little red one right here. I'm going to tap that. And that's going to restart our board. Did I click it? Did I click it? You know, that's funny. That's in running memory. I have to actually unplug the cable to make that stuff disappear. That's fine. That's not a big deal. But just know that I uploaded this blank sketch. There's nothing in it. Okay, so now that we have that stuff sorted out here, I'm going to do what I usually do. And we are going to bring things over in chunks. But since we have a lot of code, I am going to bring things over in slightly larger chunks. This will save us a little bit of time. Don't have to copy and paste as much. Okay, so above our board setup, I'm going to drop in the code that we need to start setting everything up. Okay, so as in every project we've ever done, we have to include the Arduino library. This is the code that allows us to interact with the board. If we don't have this, we can't control the board. We also can't get readings from the board. We can do nothing. We can do a big fat nothing. So this we need. And then, after we've done that, we're going to do an include for the 7-segment display, which is this library right here. Switch this over to lo-fi. There we go. Okay, so we have our library that allows us to interact with the display. Now, understand something. You don't need the library to control the component, but without it, you have to actually write all the things that a library would normally do, right? Because if you had in a book that you could flip through that says, okay, well, on page 10, it says if I grab these 3 things and follow this in the book, then it'll just work. But if I don't have the book, then I have to actually write all the code that would have filled in the gaps that the library already does on my behalf. So by pulling the library that someone already wrote, you're reusing code, but you're doing it in an efficient manner. I also don't know how to control these components without the library, so obviously I couldn't do it without it. I'm sure that's the case for a lot of people, which is why the libraries are designed in the first place, so you can interact with the components. And then we have our U8 G2 library. This is the one that we need for controlling the OLED display. That's the fancier one that we're going to see the pretty pictures on. And then we have the wire class. It says sometimes required for I2C communications. Now, what does that mean, and where in the project is that a thing, right? We have the class for the library, right? This is what allows us to interact with the display. This include is the actual communication protocol that we use to send information back and forth to update the display so we can actually see when we turn a piece of hardware on or off, the changes. Without the communication protocol, we have the ability to interact with the display, but it looks like that we have to force that include to actually get the communication to go back and forth, because without it, I guess we just can't do it. That seems to be my understanding from what I've seen in the previous days. Okay, so now we're going to do some fancy math, and we're going to define a function that figures out the amount of minutes and the amount of seconds to show on our several segment display, the 7-segment display. And the way we do that is we declare a variable. It's called milliseconds. And then we basically just do the math to turn that amount of milliseconds into minutes and seconds. When we take the milliseconds and add 999, we then divide it by 1,000 and then divide it by 60. That gets us minutes. We do a similar computation, but instead of dividing by 60, we remainder by 60. So that means that gets us the number that is the remainder after doing the division, not the actual whole number. So if you have 2.4, then this would return the 0.4 in that computation, the remainder. And then it's done in this very slick way to just do it on one line. Now, we did briefly touch on the difference between a define and a function. From what Alex has told us, who is the pre-recorded instructor that comes with this series. Thank you, Alex. You've been a great help helping fill in some of these blanks for me. A define is a macro, or writing it this way is defining the function in a very quick way. By using a define, it's then a macro, not a function, and that way of writing the code, from what I understand and the way these boards work, runs quicker. And if you're going to have a lot of code involved with your project, anywhere that you can make it run more efficiently, it's just better for the whole project as a whole. You just got to be careful with what you use in a macro, because there are ways to injure yourself by using these. As was briefly touched on, that I don't remember the details of. I just remember that being a part of the conversation. And then we're going to declare where our display is plugged in. The several segment one on pins 4 and 5, that's the same. We then make our display object and declare where those pins are for it, which is good. And then we're going to define which pins control which things. So pins 7, 8, and 9 is the confirmation lever, the systems lever, come on, thank you, and then the thrust lever, which is right there. We then have our pin for our buzzer, also declared here, which we plugged into pin 6 on our board. From here, we then make our lander display with this very, very long function name. From my understanding, this is the technical name of the display we have plugged in that is then made an object for from the library. So within the library, there are several different displays that are options in it. This is just the name of the one we have physically plugged into our board. because there's 128 pixels by 64. That makes up the entirety of the display across the top and top to bottom. If we gave it the wrong amount of pixels, or we chose the wrong board, it's not going to damage anything, but at best case scenario, we end up drawing partially off the screen where we can't see it, or worst case scenario, we get no picture on the display. And then there's some stuff down here that is a part of initializing the display. Our pre-recorded instructor didn't go too much into this, other than you need it, so we have it. Or from what I can remember. Maybe he did go into it, I don't recall. Okay, so here we define the size of our lander graphic so it can be accurately placed on the display. So we're working with a little ship that we're going to have on the display that's going to be 25 pixels high and 20 pixels wide. And that's in bits. And then to get our word done to appear on the 7-segment display, we have to then tell the code what that spelling looks like, which segments we turn on or off to actually make those words, those 4 letters appear, D-O-N-E. So these are the segments that we need, segments B, C, D, E, and G. That letter 8 that makes up the several segment display, each segment is a controllable LED. And we can just turn within each figure 8 the segments we need to make the letters or numbers that we want. For words, we have to straight up tell the code what segments those are. But for numbers, we're going to use math to actually draw that using the library. But anytime you're using words, like ON for on, right, which is the middle of done, that has to be manually declared. Which is nothing wrong with that. It's just if you're trying to do it by using a loop of some sort, you're going to have to cook up some pretty fancy math to get it. In this case, we're just going to straight up define it. Because that makes things easier. Plus, with the commentation, you actually know what this is. This is an array that says done. What does it do? It says done. Okay. So from there, we're going to find our amount of time in milliseconds and count it down. Let's see here. It says, so ensure that the calculation is done. Oh, excuse me. As an unsigned long, we will append the UL to the value below. Without this, the calculation is done in 16-bit arithmetic, which causes the values to wrap and be incorrect. So by simply saying that this is an unsigned long, there are no negative numbers. So if we started at 4 minutes and count down all the way to 0, once we reach 0, there's no possible way for us to go below that. There are no negative numbers and no symbols associated with an unsigned integer. I actually didn't know that. I found that out because I was doing a little reading into this to see what that actually meant. Which means that if your bank account could be all unsigned longs, that means you never go below 0. Who needs check guard? You just need unsigned bills inside of your checking account. Okay, so we have a little more we need to bring over. So let's go ahead and do that. Actually, I'm going to bring these comments over as well. Okay, so let's take a look and see what these comments are all about. The Arduino C++ provides the enum command to define multiple related values where distinguishing between the different values is important, but the actual values aren't. Each name is given its own value starting with 0, which can be seen by hovering your mouse over each name below. The enumerations are providing a number of benefits over manually defining a set of constants. An enum, or I'll call it an enumerator, I don't know, groups related constants in a way that clearly defines that they are variables of a single concept. In this case, the state of our liftoff sequence. This gives an exhaustive list of all valid states and no other values are valid. An enum creates a new type and a variable containing a enu value can only be assigned values defined within the list. Okay, so let's turn that gibberish into something that makes some flavor of sense. Within our example, we have the different states our ship can be in, right? We're either initializing the case of our ship, we're pending, so we haven't done anything yet, we're counting down towards liftoff, we've lifted off, or we've aborted the process altogether. Those are the only valid positions that this can be set up in, right? And then we can see here that to tie these variables to the concept, we have that in the comments here. So it says waiting for all switches to be in the off position. So when you plug the board in, you're not initialized until all three of the dip switches are in the off position, the down position. Pending is then waiting for all the switches to be turned into the on position. So we either power up the ship and wait for everything to be turned off so that the switches can be, the ship doesn't accidentally start with the thrusters engaged, which is a decent safety precaution for obvious reasons. We don't want the ship floating away in fantastic fashion. And then the countdown is activated with all of the switches in the on position. So pending is waiting for everything to be on. Countdown is everything is actually on. To which then, liftoff is the ship actually flying away. And then aborted is something happening in between the all on or all off state. That happens after the countdown has started. And at any point, one of those switches is turned off, the countdown is aborted, and then we have to go back into the initialized state where we're waiting for all the switches to then be turned off, which turns off the thrusters to the ship and turns off the computer to the ship. And then the third one was just simply the confirmation that you're ready to actually get ripping and ready to go. And if we actually hover over this here, these are all set, right? So that one is set to 0. Pending is a 1. Countdown is a value of 2. Liftoff is a value of 3. And abort is a value of 4. Now, something that I already know, for those of you that enjoy counting, is that most people don't start at 0. There are 4 elements to this array. 0. Actually, I just have 5. 1, 2, 3, 4, 5. There are 5 items to this array. I can't count. I also can't spell. Yet I do this for fun. I don't know, man. Let's try that again. There are 5 elements inside of this list, but there are 4 individual markers of where those are positioned inside of the array. As you see here, they increment by 1 as we go down in the list, but as it had already stated, we don't care what position any of those words are because we're tying this to a concept. We're going to match what we want to do further down in the code based on what word that we end up passing, which state we match. And then it just so happens to go in order, right? So we're going to run with that. Okay, so then I'm going to grab the goodies for our setup. It's actually not nearly as long this time around. The setup is actually pretty small. And then we have one more line I have to bring over, and you already know what it is. It's this one that rotates the display on my behalf. Copy that from the previous day. And then right after we set the character, we're also going to indicate I want to flip it around. So I'm just going to wedge that in here under the configuration of the OLED display. because this is related, and I could just add a comment here. Rotate the display by 180 degrees. Right, 180, because 360 is all the way around. Yes, okay. I had to think about that for a second. All right, cool. So then our void setup is code that's only run once. That's going to get us connected to our serial monitor, which is what that line's all about. We then clear our display, which, if I switch back to the bench for a moment, we'll see that the code that was previously executed is still here, even though our project doesn't include anything yet. That's because there's no clear command. Unless I unplug that board, that's going to stay on the screens that it's on because it's in buffer. It's in the memory. That's where these clear commands come into play. And when the board first turns on, it clears what was there. If I didn't include this clear command, then it would just show what was previously on before we ran the previous code, which could be problematic if you plug something in and it holds a state from last time. I do know with shift registers, even after power has been removed, the shift register will remember which things were turned on and which things were turned off. By sending a clear command, that clears all those states and you start from fresh. So you do have to be mindful of what your code does, or if components can remember the state they were in previously. That's why we have the clear commands. An excellent example as to what the clear commands do. Picture you're in your house and you turn on the light switch to your house, into your living space, right? So you're minding your business, you're watching the TV, and then the power goes out to your house. Well, the light switch to your room is still in the on position, but the lights aren't on because power has been removed. Well, you spend the next hour and change promptly losing your mind, wandering between room to room, trying to turn on the lights, and nothing works because there's no power, right? Well, you never touched the light switch in your living space. So what happened when the power company restores the power to your house? The lights in your living room come back on because the state of the switch was not reset during the power loss. That's a physical switch that you actually move up or down, but the same kind of concept is true for the states of some of the components that we use in these kits. If it can hold what it previously knew, whether that was on or off, then it's going to be where it was. That doesn't mean every component will hold that kind of thing, but some of them do. Which is why we have those clear commands. That's the way I like to describe it, because it's I don't know, I feel like it's more relatable. You know, we've all been in a power outage, and then you're sad, and then you're spending literally hours as you're trying to turn on the lights in your house, or you open the fridge and you're like, it's dark, I can't see the food that's not in my fridge. So not only can you not see the food in your fridge that's not there, there's also no food. So then when you turn the lights on, you go, damn, I forgot to buy groceries. And then you go buy groceries and then you're fine again. But until that happens, seems to happen only towards the end of the week, right? You're just like working through it and you're like, okay, all right, fine. I'm going to be in this particular place. So yeah, that's what that be about. So then we do some mumbo jumbo about setting up the configuration for the OLED display, which is just setting which font pack we're going to use. We then use some stuff here to figure out where we're first positioning text and then the height of it. My little line to rotate stuff around. And then we have to set the pin mode of our levers. So we have the thruster, system, and confirmation lever. And then these are input pins because we're going to read the state of our little dip switch, which is either going to be on or off, to engage or disengage the 3 separate checks before liftoff of our lander. We'll clear the display, and then we're going to go into our main loop. All right, and then this, I think, is a little lengthy. But thankfully, I don't think it's anything too terribly ridiculous. Oh, oh, went too far. Normally I would bring this over in chunks. We're just going to scroll through it because when I do that, I tend to get a little lost and the code is kind of long today. So in an effort to not lose myself, I'm just going to bring it over. We'll scoot back up to where we left off. There we go. Okay, so here we are in the main loop. I'm going to quickly verify this to make sure that I didn't drop anything. I don't think I did, but we'll just double check. I say that and I missed one. Oh, I see what I did. Let's see here. Where did I think I included the word loop, but I didn't mean to. So there's two loops. There's two loopy loops. Yeah. Void loop. Just get that out of there. Okay, that passed, and then right after the void loop was this unsigned belong. Let me just make sure that was in the right place. Oh, that's not. That is outside of the loop. It's outside of the loop, and it's also outside of the initial void setup. Weird. That's a weird place to put that. But to be completely fair, I don't want to accidentally initialize it multiple times. It's technically not going to change between runs because it's a constant. It may be an unsigned number, but fair enough. I mean, it's less code that has to be run each time it cycles because it's a constant. There's no business for it being in the main loop. If I wrote down a number and said this is never going to change ever for the entire length of the code, then it doesn't need to be in the loop. It needs to be accessible to the loop if we're going to use it there, but it doesn't need to be in the loop. Scope. Variable scope is terrifying. Okay, so let's see here. So it says to keep beeping and animations steady, we will attempt to have each loop take the same amount of time. Occasionally loops may take longer, but this constant defines the minimum time each loop will take to run. We're going to take a minimum of 200 milliseconds per loop. Now that is because if we go too fast, we're not going to be able to see on our displays what's actually happening with the way that this project is currently written. Okay, so let's dig into this, shall we? All right, initialize the static variables for the first time through the loop. Any value set during execution will be retained between the loop executions. Right, because as each time it loops through, it's not going to change it. So we have time remaining is equal to the countdown in milliseconds, which we did declare further up in the code. And then we have the countdown start time. It's the value when the countdown begins in milliseconds. And then we've got the beginning sequence in the initialized state, init. That means our liftoff state is going to be, let me see how we're doing this. Liftoff underscore state, that is, because liftoff is that. Right, okay, so our initialize is value 0. So liftoff state with the variable called, oh god, hold on a minute. Oh, they lost me a little bit on this. Right, that's our comment from up top. I don't remember if that's a redeem. Please tell me that's a redeem. It better be a redeem. Is that a redeem? Is someone are y'all messing with me? I am thoroughly convinced that I don't even have Discord open, but now you're gonna make me look. Interesting. Okay, so for some reason that is ignoring. Yeah, that's ignoring that. All right, hold on a minute. Let me get that out of here. That is very noisy. It should not be. I have do not disturb turned on, so those actually are not supposed to be blending through. I am sorry. Give me a moment while I situate that, because it would appear. Okay, I see what happened. Okay, there we go. Sorry about that. Alright, back to where we were. I can't remember if I had set that as a redeem. I know I was working on redeems, and I don't remember which ones I was or was not working on. But by all means, if you have channel points, you can play fun sounds. I don't have a lot. I have a couple though. All right, let me see here. So this is begin the sequence in the initialized state. Here we define a value that is toggled between true or false. That was supposed to include a y. There's a typo there. Every time through the loop. This can be used to create a beeping tone or could be used to blink text. If the loop toggle is true, this time through the loop. Okay. Then from there, we'll save where we are in the loop of how much time is left, because each time we cycle through the loop we wouldn't want to lose where we were in our countdown. So we're going to run that. We're then going to read the state of our three quote-unquote levers, right? Those are the three dip switches we can turn on or off. And then we're going to update our OLED display with the current status of our levers, which we have right here. And then let's see here. This is the primary decision part of our loop. It makes the decision based on the current state of our liftoff sequence. Switching states as different events are detected. Normally this section of code would be done in a switch case construct. However, a bug in the compiler caused certain cases to never execute. Because of this bug, hopefully fixed soon, we will use the less clear if else format, which is hard to read but gets around the bug. Interesting. A switch case version would look like this, which they do have commented out, which honestly I would have thought we would have been doing a switch case here. So we say switch the liftoff state, and then for each case, you know, if it's initialized, do this. If it's pending, do this. If it's aboard, do this. That kind of thing. But we're going to do it in this fashion. Okay, that actually explains why the code looks like that. I didn't catch that comment when I was skimming through this to make sure that I had an idea of what we were getting ourselves into. Okay. So then if the liftoff state is initialize, this is the state that requires all the switches to be in the off position. We then dig into this next system check. If all 3 switches are off, we can turn off the beeping and change the state to pending. So we're going to be beeping on an initialize. Pending means everything's off. We are standing by to start the process. And then if the thrust lever is not true, meaning that it's on, ampersand ampersand means and, so the other case has to be true as well. The system lever is not false, so it's on. And same thing with the confirmation. This is terrible. Why did they write it like this? If they're all on or all not false, then we don't need sound from the buzzer. Otherwise, the liftoff state is pending. Else, something isn't in the off position, so that means we're not completely turned off. We'll then play a loop to buzz the different interval on and off. So play a low beeping tone to indicate the switches aren't all off. So the loop toggles right here. We then turn on the buzzer pin. We set the frequency, and it says play the short tone entire loop. So this is just the tone. There's no length of time associated with this. If we had another number after this, that would be for how long. But this is just the frequency. It's the frequency of 100. The different frequencies are what allow us to make the pitch of the buzzer go up or down. And then no tone turns off the buzzer, so it stops making sound. So you're going to get that little bloop, bloop kind of thing going on here. And then the next case, so the reason this is structured as an if, else if the first if statement is true, right? We fall into it and then we reach the bottom of it, right? So we're initialized, but we're still not in the state we need to be in. Then this next statement, this next else if to check if this state is true, isn't run because the first one we fell into. If we don't fall into that first case, then we check to see if we fall into the next one, which is why it says else if. If this is true or this is not true, then do this or that. If that first thing isn't true, go to the next block of code, the next else if, and check and see if any of that is true. And we're just going to keep going through all that until either we hit something that's true or we've run out of code. That's pretty much how that's going to read. We'll then check to see if we're pending. If we are pending, that means that all of these are in fact engaged. Okay, I see why they wrote it like that. I don't know if I would have wrote it like that, but it's fine. I could read it. That then means we're going to blink the countdown on our timer before we begin the countdown. So we're going to cycle 3 times the amount of time that we're going to count down on our display. And we'll display it, we'll clear it, we'll delay the 200 milliseconds, display the value, and then delay, and then go back to the top, clear it, wait, and draw it again. That's how you blink. So you blink a set thing by drawing it, removing it, and drawing it again. And then just having a little bit of a delay in there so your eyes can actually comprehend the fact that it's actually on, then off, on, then off. And it just keeps going through that. That's blinking. That's blinking in a nutshell. Ironically, in the coding space, that is way more difficult than just simply say, blink this 4 times. It's very manual in that sense. And then from here, we'll then start our countdown timer. Save the current milliseconds when the countdown begins. And then our liftoff state is now going to be equal to countdown. To which then, when we then, so then the loop Right, so this else if block ends, it goes back to the top, and then when it does that, our state is then set to liftoff, right? So it's not equal to init, it's not equal to pending, and it's not equal to pending here either, right? So then that means that our going to start right here at countdown. Howdy, Firefox a little, welcome on in. I'm nerding out as I do. How are you this evening? And then we're going to actually go through our process of counting down. So we'll see here that we then take our elapsed time, and that's equal to the amount of milliseconds that we have minus how much time we've actually subtracted from the clock. Because you got to remember, this is a loop that's going to run multiple times, so we need to hold on to that value as we loop multiple times so that we don't, you know, count down in and out of order fashion. And then if the elapsed time is greater than the countdown in milliseconds, we have completed the countdown. The time remaining is now equal to 0, and our liftoff state is now ready to lift off. We're now exiting the alien planet. Else, the time remaining is just the countdown in milliseconds minus the elapsed time to decrease the timer, and then it will just keep cycling as it does that until you reach 0. And then if any switch is turned off during the countdown, then we abort. So if the thruster lever or the system lever or the confirmation lever, which is what these are ORs. These are pipe symbols, and that means or. So do you want bread or milk? You're not required to have both. If it's bread and milk, then you're required to have both, right? It's like making a sandwich, right? If I've already got the bread and I want to make a peanut butter and jelly sandwich, I'm gonna need peanut butter and jelly. If I want to make just a peanut butter sandwich or a jelly sandwich, well, then I have bread, and then I have peanut butter or jelly. I'm not required to have both if I'm only going to make a sandwich that contains one of those two ingredients. The same concept applies here. The levers are either going to be engaged or they won't be. But I'm going to need all of them to stay working for us to actually reach the bottom of the countdown. And then from there, we're going to then display the time remaining on our display. And we're going to display that in the format of minutes and then colon and then seconds. And then if the state is equal to liftoff, meaning we've hit the bottom of our display, we've counted down all the way to 0, our liftoff state is liftoff. We are now finished counting down, and we are now firing the thrusters exiting into orbit. And then we play our little ta-da sound by then buzzing at a couple different frequencies. And right here, 300 hertz, or excuse me, 300, is this in hertz? What is this in? We'll tell you what it's in. I want to say hertz, but it's the frequency, and I don't necessarily know if that's in hertz or not. It just says an unsigned frequency. Okay, well, frequencies can't be negative, which is fine. That's why it's unsigned. All right, so we have 300, a delay, 500, so that's do, because we're going from a lower tone to a higher pitch tone, and then we're playing a really high pitch for 5 seconds, which is what this delay is. Because if you don't have a delay in between and you just pull the buzzer pin, this will just endlessly play until we tell it to stop on that tone. And then right here it says animate final display forever. This while loop runs until the hero is reset or new code is uploaded. During liftoff, the ship graphic moves from the right side of the display, so we need to update the OLED display repeatedly. So the update display lander is the liftoff state, and then passing 3 separate trues. This line is never reached. That's fun. End of the liftoff. Why is this line never reached? Why do you say this? Why do you say that? What if I collapse that? That's between there and there. Ignore that, and then this. Interesting. All right, it's a weird place they wedge that. So while true, Update lander display liftoff state is true across the board. Now, the 3 trues just simply means that the liftoff state was a success, and the 3 levers are engaged. So then that means we've left in that case. Or if the liftoff state is aborted at some point, we make a nasty sound and then set us back ourselves to initialize state and waiting for everything to be turned back off again. And then let's see what the couple little nuggets about here. So if the loop has taken less than our minimum loop time, then delay the remaining time to keep the loops at least that long. So we're going to do a little math and then delay minus the math to get to at least 200 milliseconds. And then toggle our loop toggle between true and false each time through the main loop. Our loop toggle is going to be toggled on or off. I wonder what we're doing that all about. We did have that up top. If our loop toggle is true, this time loop the loop. Wait, what? If our loop toggle is true, this time through the loop. I'm doing the loop-de-loop and pull. Now your shoes are looking cool, okay? That is straight into SpongeBob mode. We are not tying our shoes. We're trying to debug, okay? That's what we're trying to do. I don't know if I'm successful, but that's where we're at. Oh, I hate it when I misread something. That's fantastic. All right, that silliness out of the way. The rest of this we're just gonna gloss over. We then have what we're... Oh, that's right, the maximum speed of our lander. So the lander is going to be the little graphic we're going to draw on the display. We want it to go not too fast, because if it goes too fast, we're never going to see it. We want to see it to actually move across the display. And then we're going to take our liftoff states, thruster, systems, and confirmation lever. We're going to pass them as either true or false, which we're going to read because the little toggle, which we can push up or down. And then from here, we're going to take our lander height and subtract that from the height of the display, figure out where the first position is, and then display the first page. And then we're going to go into a loop to then draw the phrase exploration lander, the liftoff sequence, and then the rest of this shows the different states of our switches. So either the liftoff, if liftoff state is liftoff, then show the text lift off, display liftoff in the center of the available space. We then do a little bit of math to figure out where to display that text on the display. And then we're going to center some text. And then else if we're going to abort, we're going to say that in the available space. And down here is the different positions that our switches could be in, on or off. This is what actually draws it on the display. So we can see here these offsets to just make sure that we don't overwrite other text that's on the display. And then this is some basic math to do. Is the thruster lever true or false, which is either on or off? If it's true, say the words ON for on. If it's false, then write the word OFF for off, which is exactly what it looks like. But writing it like this will make the display say the words thruster, a colon, and then either on or off with a space. And that space appears right here. If this space wasn't between this colon and this double quote, then the word ONN or OFF would be stuck right up against it with no space. But we add the space so that it's easier to read on our eyes. The code doesn't care whether the space is there, but if it's not legible, it's not very useful, then it isn't. We do that for all 3 states. Thruster, system, and confirmation. And then what do we have here? Our countdown. And then draw a picture of our lander on the right side of the display. During the liftoff, this will be animated by changing the lander height variable outside the do loop. So the display lander width and height And then while the next lander page, set the height of the lander image on screen to animate liftoff image. Increase the speed to max during liftoff. This value is only changing outside the first page or next page loop, and sets the new height for the lander to be drawn the next time the OLED display is updated. So if the liftoff state is in liftoff, move our lander graphic up on the display based on our current speed. Now our lander height is going to be minus equal to the current lander speed. Now the current lander speed I believe is 5. We scroll back up here. Current lander speed is 1. Okay, so it's set to 1. We then take our lander height and subtract from that the height. So by subtracting it, it's going to move it further up the display. And then we're going to start again at the bottom. To accelerate, increase the movement speed until we reach our max speed.
It's not a thing about making it accurate.
We're going to be taking our current lander speed after each loop and adding an additional 1 to it. So we're going to start at a speed of 1, and then at the next refresh a speed of 2, and then a speed of 3, and then our max speed is 5. So we're going to go zoom on the display. And then let's see here. So helper function that returns a different string for each enumeration state. Liftoff state to string, liftoff state, and that's our switch case, the different states. All right, and then down here are our functions. Our display counter is what's actually going to allow us to update what's on the display, the several segment display, excuse me. And then from here, we're then going to show what's actually there. So this is going to show the minutes and seconds between these two. And then this section down here is all the math that actually draws the spaceship. The image is drawn in frames by providing the X location. I think that's an offset of how many pixels in each direction. So the X location is 7 pixels in length, the Y location, where's that passed from? X location, Y location relevant to the upper left-hand corner. What are these other values it passes? Does it actually say that here somewhere? X, Y, W, and H. Okay, alright, so that's our X location, adding 7, our Y location, and then the height and width of the top of the ship. And then the same thing to figure out the ship's center, the pod sides, and then the nozzles. We're just going to file that under trust the system, because that was what was provided to us. So now that we've gone through it all, let's upload to the board and see if it actually works.
But it's not a thing about making it accurate.
All right, so we're going to upload this crazy bananas worth of code.
Getting all the errors out. It's about getting it to do it.
Okay, so I had left all of the switches in the off position, which immediately put us into the pending state. So I want to see the initialized state, so let me actually toggle one of these and reset the board. Which is hard to do without looking at it.
You know, take a, if it's an accident that's an error that feels good, then you leave it in. You know, you want those.
Weird, I'm resetting this, it doesn't seem to be resetting. Let me just do that. Alright, so I already know I got a problem because I got two switches in the on position and it's only recording one of them. So that means either I have something not where it's supposed to be plugged in, or I got a loose wire. So we can see here that our display is a little angry with me. Yeah, off, and on. So if I take a look here, let me check and see if everything is fully seated. Which it might not be, to be honest with you. Those are all fully seated. I cleared the Blender display and I'm still not getting the reset. Well, that's fun. That's strange. I don't know, I'm not even getting anything now. Huh. Let me resend the code. Alright, there we go. Alright, now we're done uploading. I'm not really sure why I had to re-upload it, but let's see here. Yeah, we'll be able to troubleshoot where we're at here. So we're going to turn on the first switch, which is not registering the first switch. So let me see what's up here. So we got 5 volts there. Right, that's that white wire. Which does not seem to be fully functioning. Well, let me check the other switches. Turn on the second one, that's the confirmation switch. And the system switch, so the thrusters is off. That means I don't think I plugged a pin in one of the right places. So let me scroll backwards in the example, and I will double check the pin position. I think that's a simple mistake I made. Let me scoot back up to the diagram, because I already thought this was a little strange when I was looking at it. So the pins were across 6, 7, and 8. Now if I look at this, this is across pins 0, 1, 2, 3, 4, 5, 6, 7, and 8. Well, they look like they're in the right place. Alright, so they're all claiming to be off right now, because I just unplugged them all. And then we'll plug 6 back in. It would appear that our white wire is either not getting a good connection on the board side or not. The rest of these seems to be okay. Right, I've got several off, several on. Okay, let me check the connection here and make sure these are firmly seated. It's likely just a loose resistor. Let me get a little closer here. This is the part that requires a close-up view as to what on earth I'm doing. It also requires to make sure I put these in the right place, because I did put these all back to back in here. That might not necessarily be true. Let me move this up a little bit. I can see this a little bit better. So move that up there so I can see that. And then we're going to move each of these up a leg. I apologize, I am doing this off camera because it is a little difficult to see what I'm doing. So I got that there, I got that there. And then if this still doesn't produce what we need, I'm gonna change out these jumpers for a different set. Something I find very strange is that I hit the reset on this and it does not seem to reset the project. So let me upload it again. Something definitely seems to be a little funky in that regard. Strange, it's behaving like it's not even getting power. Well, I went from having something to nothing. That's interesting. I wonder what that's about. Let me take a closer look here.
Let me take a look and see what we got here. Pull up our diagram. Going to grab a flashlight. I'm gonna double check our positioning. Oh god, that's bright. Woo. Okay. Because either something is loose or damaged something. I don't think I did. Maybe I have. Okay, so our display should be plugged into 5 volts. It is. The next thing is the brown. I don't believe I shorted any of those out. So it's supposed to be 5 volts on the top side of the switch pack, which I did. And then our probes go on the same electrical line as the resistors that then sync to the ground. So those are our pull-down resistors, which I do 1 per here. All the same resistance. Let's see. So well, you know what I don't have in use? I don't have... I have 1 less ground connected. I wonder if I have to ground both sides of this developmental board because of these pins are on the other side. I wonder if that's why it's misbehaving. Let me go ahead and connect that. Let's see if that makes a difference. 8, 9, 10, 11, 12, 13, wow. I don't really have any reason to believe that I need both of them connected, but since it's not working, I'm certainly open to try. Oh, let's try it again. Dragonus! Hello! Hello! How are you? I'm troubleshooting the madness. What have you been up to this lovely evening? You subscribed. Thank you. Thank you. It's appreciated. It helps me keep this chaos running. You need more troubleshooters in your life. Don't we all? My goodness. Let's see if that works. Unrecognized command. Oh, come on. I'm gonna use the full word, I don't care. There we go, got it! For those of you who've been lurking with me, by all means, please give Dragonus a follow. He's an Amazo bean. Ha! I beat you to it, I had to use the long form of the command because I couldn't remember the shorthand. Nah, it's fine. I'm just happy I could spell chaotic. I have enough trouble with words, let alone names. Trust me, ask anybody who knows me, especially the people who work with me. I don't do well with spelling. Trying to get folks into VRC to find me. Oh yeah, that's fair. Oh, that is a solid point. I'm glad I'm not alone there, Sib. I'm glad I'm not alone. Let me see. I would love for this to work. But right now we have got a ton of stuff connected and we are not even getting anything even out of the display. It's right. Which means I probably did something bad. I just don't know what that is. Probably just yet. Well, I had the extra ground. Let me plug it back in. Let's see if we can get a pretty picture or not.
Okay, good. And that was my headphones. There's a lot of things I'd be okay with falling over in this office, and that is one of them. Alright. Let's plug this back in and hope for better things. I'm hoping. I don't know how well I have to be hoping, but I'm hoping. Alright, so we got it connected. I don't like that we're not getting anything on the display, so I'm just going to upload that again. If this still doesn't behave, I might just re-grab the code in a block, pull it over to the project, and re-upload it. Maybe I did miss something. I thought I was a little better with the way I copied it this time. But we'll see. Okay, well, that's at least good news. I'm at least getting something on the lander display this time. Well, that's good, that's good. Alright, let's see. Alright, so let's... Hopefully this is, like, seated now, right? So I can turn these on and things are going to work, please. Well, we're almost there. The first switch didn't register. I'm not really sure why either. So that means that it's really not happy with this gray wire. Alright, then let me swap out the gray wire for another one. I have extras. At least I think I do. Yeah, I do. Alright, cool. So we're going to swap out... I'm not even going to peel them all apart. I'm just going to swap... I'm just going to stick an extra wire in here to read this first one, the orange. And then this is going to be the stand-in for... pin... Get that out. And then we're going to plug my purple wire back in. And plug that back in. I'm going to put this orange as a stand-in, because I can't seem to get that one to play nice. And then this one was the buzzer. And the buzzer fell out. So let me see where the buzzer went. The buzzer was in pin number 9. Okay. And then... I'd say this is 9. Right there. Alright. Okay, let's see what that gets us. Oh, I didn't have to reinitialize it that time. That's actually a better sign. No, I'm still not getting anything from that switch. What the heck? Alright, let me check the code. I wonder if I mislabeled one of the pins. Might have. Alright, so I'm not getting a reading on pin number 6. Let's see if I'm actually supposed to be plugged into pin number 6. Because right now, this says... Yeah. 6, 7, and 8. Well, I'm not getting anything on 6, so let's see what the code says. Well, that will definitely explain why I'm having a bad time. Alright, I'm going to show you what's going on here. There's a mistake in the example.
Alright, let me show you what we're up to here. So I was following off of this example that's up here, right? And if we follow these little leads, we can see here that 5 is a part of our multi-segment display. And then we start at 6, 7, and 8 for the switches. Well, let me show you what's down here. 7, 8, and 9. Well, that's not going to work very well now, is it? So the code doesn't actually line up with the position of our dip switches. So that means we need to fix it. So the display was supposed to be on 4 and 5. Which is 4 and 5, which is in the correct location. So this is supposed to be 6, 7, 8. Let's go fix that and see if we can get this sorted. That's going to be near the top of the code where we define the pins. So this, right, so all right, so before I change that, hold up, so we can see here the buzzer is currently on 6, right? Now if I take a look at the example, the buzzer is wired into pin number 9. So we can see a clear disconnect between the diagram and the code. That's why it's not working. There's an actual mistake on day 24 of the 30 Days Lost in Space kit. This, I'm going to see if I can submit some notes to crafting table, because this needs to be fixed. That's a pretty nasty boo-boo. If you're not, I mean, I guess if you're this deep into it, that you hopefully would be able to note that, but that's a boo-boo. So let's shuffle some stuff around here now. Yeah, I have to wonder the same thing there, Pyrex, because that's no good. So from my own reference, so that I can get back to this later, I'm going to comment out the original. And then I'll do this as corrected. Actually, I'll do that in all capital letters. And then do the same thing up here. These are all going to have to get shifted. So copy that. I'll paste that. Then I'm going to comment these out. I'll do the same thing. Okay, and then that is going to be 6, 7, 8. That should match where I actually physically connected these. 6, 7, and 8. Okay, that should line up now with the actual code. So now I'm going to save this. I'm going to verify it. Now we have to be careful. I did change some stuff near the top, and we only declare these once. So as far as the board should be concerned, I'm changing something that shouldn't technically affect anything else lower down in the code, other than just telling the hardware where the things exist. So, okay, with that taken care of, let's go back to the bench. Let's re-upload our code and try to flip our switches around. Okay, well, I can tell you right now, there's the first thing that we know that is working. Yeah, that was a mistake in the example. We are in the initialized state right now, and that buzzing is to indicate that the switches are not all in the off position. So to get ourselves ready, I'm going to turn these off one at a time. So I'm going to turn off the confirmation, the system, and the thruster switch. And that should update in the loop, I hope, because they're off right now. They didn't redraw as being off.
Well, let me turn them on and see what we get. Well, good news and bad news. There's still something incorrect because the state never updated on the display, but the countdown started. So if I shut one of these off, that indicates we aborted, but the lander never updated. So here's what we're gonna do. I'm gonna restart the whole project. And then I'm gonna reinitialize the code again. Well, it did mention that there was some bugs in the code. I wonder if these might be related. I'm bothered that I'm still not getting anything on the display when I do that. That means that the wire that I actually stuck in here didn't have anything to do with it. It just so happened to be a bad pin out. Uploading. Upload successful. And I'm back to having nothing on my display again. It's not good. It's seated. Yeah, something fishy's going on here. Because I'm not getting anything on the display, but... Indicate I'm aborted. Reset the project. I'm building and uploading again. That seemed to get that display working before. That's a really nasty bother that still won't light up. Those are fully seated. Those are fully seated. That one was omitted. All right, hang on. Let me get this extra set of wires out of here for a second. This orange one I put in here, I can actually pull this out and plug the other one back in. But it doesn't need to be in here now, because I found what was causing the project to misbehave. Well, at least in that regard. Okay, so we got that. Plug this back in. We're still not getting anything. Alright, let me pull up the serial monitor and see if I see anything in here. I know we started the serial monitor, but I don't think there's anything we're putting out to it. Let me re-upload, and we'll see what we get. Yeah, I'm checking my connections over, thank you. Because it's giving a tough time here. Alright, let me just double check. Let me just quickly skim through the code here and make sure that those pins aren't mislabeled anywhere else in here. We got the pin was 4 and 5, the thrusters are 6, 7, and 8. And then the buzzer's on 9, which we can hear the buzzer now, so that's working. There we go. Okay, it was a loose cable on A4. It wasn't fully seated in the board. It's weird because it was seated the whole way, but once I spun it around, I guess it made better electrical contact. Okay, let's try this again now. Now that we can see things. Hopefully that means we're good. I hope we're good. All right, confirmation is on. Systems is on. Thrusters is on. Countdown is active. Okay, all right, now we're actually seeing what we're supposed to. All right, cool. So now if at any point we were to turn one of these off, we should see an abort here. So let's do that. We've aborted. And then it resets, and now we have to get back to the initialized state where we turn all the systems back off. We're now down to pending. So now we could turn these on one at a time. So we got thrusters and system and confirmation. Okay, so now we're just going to wait that a little bit of a minute, and then we should see the actual animation, as long as everything else is correct. You are correct. You are correct, Pyrex. It has got a sense of humor. I'm not laughing, but I know it certainly does. I have to almost wonder if the mislabel of the pins was intentional for something. Like, I'll tell them that it's wrong and they'll be like, haha, you found it. Like, oh. Honestly, yeah, I mean, but it was weird because the lead fit better when I spun it around in the board. Let's go. There's our liftoff sequence. We're done. And our little ship is zooming away. Let me pull that up here. I'm going to try to move this up without unplugging anything. Isn't that cool? And now, from what it said according to the comments in the code, if I turn any of these switches off, that should not affect this. Let's see if that's actually true from what I read. Because we should be trapped in a forever loop right now, because all the state of all these being active and us reaching liftoff means that turning the switches back off shouldn't affect anything, and that seems to be true. I have turned the 3 dip switches into the off position. Our display still says done, and we have left into orbit, just like we planned on it. Okay, so there is a little bit of fanfare that I found that comes with the example. So let me pull that up, because I found this is kind of cool. So let me find that here for us.
My mark, you'll flip the 3 levers in sequence to initiate the countdown to launch. This is what we have been waiting for. We'll only have 1 shot at this. Flip lever 1 to initiate thruster power. Now. Well done. Flip the 2nd lever to power supplemental launch circuits on my mark. Now. You're doing perfectly so far, Explorer. Now, ready yourself to flip the 3rd lever and initiate our countdown. On my mark. Now. The sequence successfully initiated, Explorer. Performing failsafe diagnostics. Data readouts normal. Diagnostic shows power systems are humming beautifully. Your moments from freedom in the stars. Hold tight now, Explorer. Ready your body and mind for liftoff. Go!
A very chunky spaceship.
I didn't think we'd make it. You did great, Explorer. I mean, you covered so much code and wiring in such a short span of time.
No, it was long.
You rock.
It was months.
We're in space, where we're meant to be. Well, not quite where we're meant to be, but once we're at the mothership, we'll... Oh no.
Oh, that's fantastic. I love that. Oh, that's just delightful, isn't it? I think that's fun. Yeah, so that makes that up. Moving forward, we're not done. We're not done. This is only day 24. We've still got up to day 30, which is the remainder of the exercises, which is 6 more. Because today is day 24 out of the 30, which is pretty cool. A little bit of a spoiler, day 25 is a creative day. So when we come back to this series, because I'm probably going to rotate a game in for next stream. I like rotating between the electronics and games because frankly I find it fun, and this could be a little heavy, so I like doing that. So we're gonna do that, and I want to see if I could potentially find us something that's a little easier to understand on making graphics appear on that display. I very much want to use that display in the creative day, because I don't quite understand everything that's here. Like, I understand that you need to be able to position the things on the display, right? You have to know where the text is, and then to draw the next line of text, you need to know where the existing text is. So there's a little bit of math involved in placing things on the display. But what I don't quite understand is the graphics side of things. There's some math that's involved in making that little... To me, it looks like a briefcase, but they said that's our spaceship that was zooming across the display. And I would love, I don't know how possible it is, but I would absolutely love to put one of my emotes on the display. Like, I don't know how difficult that is. I'm half wondering if there's either a library or if there is a website that can convert an image into the code you need to upload to the project, like something to middleman to be able to do something cool like that. So that's going to require a little bit of research on my part, which is also in part as to why we won't be doing this day 25 for the next stream, because I'm going to need some time to research that. Right, yeah, I would need to be able to pixelize the art, but providing it to the board in a method it understands, that's the part I'm having trouble with. Because realistically speaking, if I could turn the image into either the hex positions or just simply the right outline to where things exist, well, I guess that's the challenge, right? Because I know we have a display, I know we can turn in the individual pixels on and off, but telling it which ones to turn on and off to get the thing we want, well, that's the trouble I'm running into. I know I'm not the first person to work with this display, so I'm very confident that I can make that happen by just wandering through what's already out there, because I cannot possibly be the first person to put a funny graphic on one of these things. And I'm certainly not going to be the last. So I want to toy that into Day Creative 5 and then potentially come up with something that I could tie in the other things we have here. Now, a little bit of a spoiler. I have been working on a project in the background for our first PCB make, where we build an actual project on a physical board. I love a good spoiler, I know, right? So I don't know what stream that's going to fit into. Right now I only have some of the things I need to actually show that on camera. I want to see, first I need to check to make sure that, you know, what I have actually works. It should. But as long as that plays out well, we're going to be fitting the first make on this channel of doing something with integrated circuits on a permanent board. So I plan on doing more of that, and I do plan on involving you all in the beginning of the process, wandering through the process all the way up to the manufacturing and then building of the thing on the channel. Right now, I kind of jumped from the choose a thing, design it, manufacture it, and then we're going to pick up at the building stage just to make sure that I understood everything up to this point. Because not only do I want us to do it together and make a project, I want to make sure that I have a decent understanding of how it works before I try to do it with you. That way, I don't, trip into a pitfall and ruin the first community project. The goal is to have an understanding of how the process works, and then pull the community in and we do something together. So I'm not going to say any more on that. For some of you who've talked to me directly, I've told you what I'm working on. But for all you who watch me here, more is going to come on that. Yeah. So don't worry, even though that we are progressing through this 30 Days in Space kit, the electronics, I can tell you for a fact, is not going away on this channel. It might not be as prevalent once the kit's away. I'm still going to be mixing in games with electronics and probably do a little bit more computer stuff too. So there's going to be a mix of things that we're going to be doing here. And that's just one of the directions that we're going to be heading in. Because honestly, frankly, I find this kind of stuff fascinating, and to be able to design and build my own cool thing to share with all of you, I find fascinating. Because this is something I've always loved growing up, was toying with electronics. And I mean, I repair stuff. That's just what I do. And that ties into something I enjoy. So that's why I'm here to share it with you. With that, I think we're about wrapped up here. So let me see who I could wander us off to, because I see a lot of beans on right now. Let's see who we have floating around. Let's see here. Now, one of the beans I thought was on. She must be done. Am I blind? Unless this list is lying to me. Hang on, let me check. Okay. Alright, they are offline. Okay, so my overlay is not lying to me. I love it when my overlay lies to me, and it's like, haha! Huh, I'm not going to show you correct information. Like, well, great, thank you for that. Well, we could do art. I see some people playing games. Okay, alright, I know where we're going. I don't normally do raid messages, but I'm feeling the mood for a good raid message. So let me see here. We're gonna quickly put something together. I have something in mind. Check one small thing. Let's share I believe. What a terrible time for an ad to pop up. Don't you love that? I know I love that. Oh, it's XE. Oh god.